Hello, this is the second video of a special properties video. The last one was on complementary angles. This one is on something that are called trigonometric identities. There are a bunch of identities, but we only have to look at two this year. An identity is an equation that we can use to help solve complicated problems by making them simpler by using the identity. It'll make sense as I go through. So here you can see I've got tan of theta is what we're going to be looking at. And I've got my usual unit line in the first quadrant just to make it simple what we're doing here. And as usual, I've labeled the vertical distance as being y and the horizontal distance as being x. Okay, so what does that mean in terms of tan? If you remember, our redefinition of tan was simply talking about the gradient of that line. So in general, we would say that the gradient is y over x, like so. But we also know that y is the sine of theta here. If I draw theta in, so y is the sine of theta and x is the cosine of theta, which means we have this special relationship, which is that y being sine of theta and x being cosine of theta means that tan of theta equals sine theta on cos theta. And you are given that particular identity in the information booklet. Let's use this particular property to solve some problems. So I've got here, solve sine of theta equals cos theta. And let's imagine that we're solving for theta between 0 and 2 pi, just to keep it nice and simple. Okay, so I need to, if I divide both sides by cos theta, so I'll do it in a different color so you can see it. On the right-hand side, I have divided cos theta by cos theta. Anything divided by itself is just 1, so I can replace the right-hand side with just 1. The left-hand side is sine theta cos theta. Well, again, based upon the identity we just worked out, sine theta over cos theta can be replaced with tan theta. And so the new problem just becomes tan theta equals 1. Again, remember, the name of the game with equation solving is to get the equation so that it's a single trig function on one side and a value that we know something about on the other side. So we've got tan theta is equal to 1 here. Here, at the start, we had a trig function on both sides, and that made it difficult to deal with. What do we do from here? Our usual steps. Let's work out the reference angle. When is tan theta hat equal to 1? Well, you can refer to your information sheet, but it would be pi on 4. So theta hat is pi on 4. The next thing we can do is draw our quadrants and say, well, we've got tan being positive here and tan being positive here. C-A-S-T, all are positive here, T is positive here. Then we can draw out our angles. So it's going to be this one or this one. And theta hat's in there. Oops, wrong place for that one. And so we can conclude that theta is equal to, well, the first quadrant angle here is just going to be the same as the reference angle or the base angle. So that's pi on 4. And then we've got this one here, which is all the way to pi and then another pi on 4. So that's going to be 4 pi on 4 plus pi on 4 is 5 pi on 4. And they are our two solutions. Next one. The second identity works like this. I've got a right angle triangle, just like we always have been constructing them. And I've got a hypotenuse of 1 for the unit line. And now I've got, as usual, the x-axis here being x and the y-axis. Sorry, I'll say that again. The x coordinate would be xy here. So it's length x and height y. And if I use Pythagoras' theorem, I get x squared plus y squared is equal to 1. That squared plus that squared equals 1 squared, which is 1. But what does x equal? Again, on the unit circle, x is equal to cosine of theta, right? Because cos theta equals x on 1. So x is equal to the cosine of theta. And similarly, y is equal to the sine of theta. So what does that mean for x squared plus y squared? It means that x squared is actually cos theta squared, and sine squared is sine theta squared. And so we have this relationship that the square of cos theta plus the square of the sine theta value will equal 1. Now, a little bit of terminology here. Because squaring or cubing a sine and cosine function happens so often, to make it look tidier, it's just a look, we tend to put the square next to the cosine, and we may or may not have brackets after the function like that. You will see this all the time. Cos squared theta plus sine squared theta equals 1 is how you say it. Cos squared theta means take theta, work out the cosine of theta, let's just say it's a half, then square it, you'd get a quarter. If it was root 3 on 2 for sine theta is root 3 on 2, square it, you'd get 3 on 4. Okay, that's how you do it. So even though it looks like this, it means sine theta and then square it. It's because it tends to end up looking a lot neater. So let's have a look at a couple of problems and then we're done. Cosine of x is equal to 0.6. What is tan of x? So, step number 1. Let's work backwards a bit. To work out tan x, I need to know what sine x is because tan is sine over cos. So what I do first of all is I use by the way, this is called the Pythagorean identity, this one, because it comes from Pythagoras' theorem. So I use my Pythag identity to write cos squared x. Notice how I'm not putting the brackets in this time. Sine squared x equals 1. So it doesn't matter whether you put brackets in or not. Cos squared x plus sine squared x equals 1. And now I'm going to put in the value that I've been given for cos squared, which is 0.6. Notice how I've got 0.6 all squared? That tells me that sine squared x is equal to 1 minus 0.36, because 0.6 is squared is 0.36. So 1 minus 0.36 is equal to 0.64, and then you can square root that. This is something that would more likely to be in the calculator section, but look, the square root of 64 is 8, right? So it's going to be 0.8. So 0.8 times 0.8 would be 0.64. Okay, so there's the solution there. Is it? No, because I've worked out sine x, but I haven't worked out tan x yet. But I worked out sine x because I can now use this particular relationship in order to finish off the problem. Sine x we just worked out is 0.8 over tan cos x, which is 0.6 is what we were given. And if you multiply top and bottom by 10, you get 8 over 6. And if I simplify that fraction by dividing top and bottom by 2, that's equal to, I'll just do this in case it doesn't make sense to you. Oops. Multiply by 10, divide by 2, divide by 2, and 4/3 would be our answer. Remember that sine and cosine have to be between 0 or negative 1 and 1, but tan can be pretty much any number. So having it as 4/3 is legit. Okay, let's have a look at the next problem, and this will illustrate something else. Sine of x equals negative 3/5. If you can, have a crack at pausing the video and having a go at it yourself, and then come back. All right, you either did or you didn't. It's the same idea. We start off with sine squared x. Oh, I've got it in blue. I'll keep it in blue. Sine squared x plus cos squared x is equal to 1. We substitute the value that we're given, which is sine x is negative 3/5. So that becomes negative 3/5 squared. Note the negative is inside the brackets there. And then when I square it, the brackets will the negative will disappear. So I've got 3 squared is 9 and 5 squared is 25. Now I'm going to subtract. I'm going to do this in a couple of steps, I think. I think you're okay with this, I hope, by now. I need to, oh no, I won't. I'll do it in 2 steps. I've got 1 minus 9 over 25 by subtracting 9/25 from both sides. Then I need to get that down to a single number. So I'm going to change 1 to 25. And that will leave me with 16 over 25 as what cos squared x is. But I need cos x, so I'm going to square root both sides. So the square root of cos x is cos x, cos squared x is cos x, and the square root of 16 over 25, well, you can square root the top and the bottom of that. So the square root of 16 is 4, and the square root of 25 is 5. Now here's something that I didn't do last time, and that is when I square root both sides of an equation where there's a variable involved, it means the square root really should be plus or minus. So it's in fact plus or minus 4 over 5. So which one of those is the actual solution, or could both be the solution? Well, to answer that, we need to go back to here. The quadrant that x has been restricted to is 180 to 270. So we have to go since, and the way you read this again is you have to sort of almost write the whole thing back and then say it. Since x is between 180 degrees and 270 degrees, cos x must be negative 4/5 because it's this quadrant here where cosine is negative. That's where 180 to 270 is, and only tan is positive in that quadrant. So cos x is negative 4/5. So if this was a test and you wrote plus or minus 4/5, you'd lose probably half a mark, maybe a whole mark. To get full marks, you would have to write something like this, or write negative 4/5 and plus 4/5 and then put 4/5 is wrong, or something like that. Some way of saying that you understand that although there are two solutions, only one of them is correct. Okay, that should be enough to get you going.